Okay. So, all right. So welcome to the Karpenter Working Group for July 9th. A little bit delayed for American Independence Day, but thank you all for coming for a new time. So getting right into project updates, I think we'll start with our usual spiel. The V1 APIs are coming, so if you haven't already, please take a look at the V1 API and roadmap proposal. We are starting to get all of this merged into both the upstream Karpenter repo along with the AWS provider repo. So if you're interested to see progress there, of course, you can go ahead and check that out. I think that's all of the updates we really have for V1, more or less the same as normal. So going to pass it over to Nick to talk about Consolidate After.
Hey, so some updates on Consolidate After. We've been doing a lot of discussion internally about trying to figure out what the right solution is here. So previously there was a PR that I had out for it, um, and we decided not to go through with it, and chase another alternative. The reason we didn't want to go with the proposal that we originally had was that there was a lot of computation that needed to be done to basically figure out consolidation decisions. And reasoning about like what makes a node underutilized was really tough for the reasons that we currently have right now, which is why we have like things like a timeout on our consolidation. Um, it's a much harder problem to solve when you have really large clusters, and we want to make sure that every single second that we spend on trying to calculate a consolidation decision, we understand that that's more cost on the user, because the longer it takes to find a decision, the longer the node is up. So ultimately, we decided not to go with the proposal that was originally there. And one thing that we're running with right now is that we're going to start using this consolidate after as a way to kind of gate candidacy for nodes. What that means is currently, like the way we think about expiration and drift is that nodes are considered a candidate after they've reached some status condition or they've reached some condition, and then we just mark the node as like we just mark the node status condition as true, and then our disruption controller will look for nodes that have those status conditions and then try and batch them together to do disruption commands. What this effectively means is that for consolidation, the consolidate after will refer to how long it's been since a pod was removed or added to a node. Um, this kind of more maps to how we've heard people want to tune the consolidate after for like consolidation's aggressiveness, is that like there's like some CI jobs that need to be rescheduled, and after a pod gets deleted, I want my node to be around for X amount of seconds or X amount of minutes because I know that I have more pods that are gonna come in within that period of time. And so consolidate after will refer to like when a pod gets removed, but also when a pod gets added. And a pod getting added, we also want to consider that utilized for time being, because you don't want to have recurring pod disruptions. So like if you can imagine it this way, is that there's a pod that comes in for a CI job, and then it goes down and comes back up. Um, if you try and drift it or you consolidate it, then it would go and get scheduled to after like the next least utilized node if you're using the least allocated for the kube scheduler. And then we would then consider that node not, currently we would consider that node as not a candidate for 10 seconds, but then after that, we would try to disrupt it. And so the way that consolidate after would work is that if you have that set to a minute, you can basically prevent recurring pod scheduling, rescheduling and disruptions, understanding like maybe your pod only needs actually a minute to run. And so then you'd want to consider that node underutilized after a minute. Um, yeah, so I put the idea into the consolidate after PR that I originally had, but also into the issue. Um, I'm gonna start implementing it, and if you have any feedback on that, please do let me know. One thing that I did call out, but I'll call it out again, is that the way Karpenter does consolidation is we prioritize nodes that have the least amount of pods on them, roughly. And that goes it's kind of the least compatible with the way that kube scheduler defaults to, which is it prioritizes putting pods onto nodes that are the least allocated, which means it has the least amount of pods on it. So there's currently like with the default of the kube scheduler, there's currently like a battle of like Karpenter tries to disrupt nodes that the kube scheduler is scheduling to. But on the other hand, the most compatible, if you were to think about it, is the most allocated kube scheduler strategy, which means that like pods could schedule to nodes that have the most pods on them. But yeah, feel free to ask me more questions if you have any questions.
Okay, if there are no questions, go ahead and move on to the next point. Got the ODCR RFC. I don't see either Jonathan or Thorben here to talk about it. So Nick, unless you had anything you wanted to add, I can give a quick blurb.
Yeah, the ODCR stuff, I think there should be comments in there, but we've basically been going and working with Thorben and Garvin to kind of see what the right solution should be here. There's not much updates to give. I think we're still aligning on some things that if you're interested, you can go ahead and read the RFC. But I think that we should be able to give some sort of like like a more concrete update in the next working group.
Okay, sounds good. So, all right, unless there's anything else there, we can go ahead and move on to the node overlay RFC. So I don't know, Alice, if there were any updates or anything you wanted to say here.
Yeah, I've mostly been addressing comments on this. I've left it up and there's a ton of comments from you guys, so thank you for all that. I think we're broadly at consensus between the maintainers on making progress on this. I wanted to leave this open and make sure the community had an opportunity to kind of read and comment. Is anyone here like invested in this idea or this feature and wants to comment? I just want to make sure that we're using people's time effectively. All right. Well, maybe just for a very quick overview of what node overlays are, is it's an advanced feature to teach Karpenter about scheduling things that it can't know about. So say, for example, there's some external price details that Karpenter doesn't know about. You can teach it, how to evolve the optimization algorithm based off of that price. Similarly, we can teach Karpenter about extended resources, and there's a whole scope of problems in the space that node overlays attempts to solve. So if you find yourself kind of interested in any of these problems, I think there's maybe some relation to CAPI, Michael, because you kind of have this problem as well of trying to teach Karpenter about like what all the CAPI instance types are available. So anyways, if you haven't had an opportunity yet, take a pass at the RFC. But otherwise, I think we have kind of consensus on the maintainers to move forward with an alpha of this. And so that's probably going to be coming in the next couple of months.
All right, sounds good. Thanks.
Can I ask a question?
Oh, yep.
Hey, does this also support the node overlay also supports sort of new instance types that AWS adds? Like basically we had an issue or a struggle where AWS releases a new instance type, but our customers are still using old version of Karpenter, and we have to push them to upgrade. So would this node overlay somehow allow us to also introduce new instance type that maybe AWS has recently made available, if that makes sense.
So Karpenter should automatically discover all instance types by calling, or at least the AWS provider for Karpenter will describe instance types within EC2. And so you should be able to run new EC2 instance types on old versions of Karpenter. I think there are some edge cases around some of our specific integrations. So for example, if you rely on the pod ENI's extended resource in the node, we'll have outdated information on that. And so you could run into some scheduling challenges. Is that specifically what you're referring to, or is it another problem?
Uh, I think what you're saying makes sense. What we saw was within Carpenter, there was AWS SDK that has these instance types pinned down, and we could not find the one that we are looking for in that list. And looks like, new release of Carpenter has that version. So our assumption or understanding was that it's probably due to this reason that somewhere these AWS offerings are hard-coded in the AWS SDK, because of which we don't see the new types. But based on what you're saying, I think maybe we need to relook into this and yeah, investigate this a little bit more.
Nick, you can correct me if I'm wrong. I think that we actually do both. So I think that we try to discover them if we have network access. So for example, if you're, and we definitely do this for pricing, we bake in static pricing data, and that could be delayed. Like say, for example, you're running Karpenter in a VPC that doesn't have access to the pricing API. Maybe you've shut down network access to that for security reasons. We still have pricing data for some instance types. And so depending on the environment that you're running in, we have this kind of like fallback data on what instance types and their offerings and their prices are. But if you're running in a networked environment where you can let Karpenter discover these things, we should happily discover them. So it really depends on your setup.
Okay, yeah, I can look into this. Thank you for answering that question.
Okay, yeah, if there isn't anything else, I think we can dive into the community questions. So starting out with this issue, I do think I saw this go up earlier.
Yeah, I just wanted to kind of bring it to people's attention and see if there were any kind of comments or what, or, just kind of get a feeling for what people might think. This is coming up because it's kind of an issue for Cluster API, but the more I talk with users, who are getting into kind of alternate or not alternate, but more like managed service topologies for Kubernetes, where you might have like hub spoke clusters, or you might have managed control planes. I initially looked at the idea of having like a multiplexing client for the cluster API that could allow like different resources to have different kube configs depending on where they are. But as we're designing our proof of concept, I realized that looking at the core Karpenter, this might also be solved by just having an option where when a concrete provider invokes the core kind of operator, if we were able to pass in two kube configs, one for where the nodes and pods will be, and another potentially the same for where the Karpenter specific CRDs will be, such as like node pools and whatnot, that we could support kind of a more dynamic deployment of the Karpenter binary. And what I mean by that, and the problem, that I'd like to solve is, let's say I'm running a managed Kubernetes service, and the topology for my service is such that I have a hub cluster that contains, control planes in different namespaces. And then I have spoke clusters that are basically just, worker nodes. I would like to be able to deploy the Karpenter binary in the hub namespaces and keep the node pool and potentially node claims and node classes there as well. But I need Karpenter to be able to look at the workload cluster to detect the nodes and pods, so that it can do what it needs to do. So I thought that might be one way to solve this, and I just wanted to see what people here thought, or if that's something that might be worth investigating. So yeah, I think that's pretty much it.
One of the challenges with what you're talking about is Karpenter's APIs are cluster global scoped. So node class and node pool are both cluster global because nodes are global. And so if you were to have a multi-tenant cluster that was hosting multiple Karpenters and multiple and the node pools for each of those clusters were living in that central controller, you'd have the opportunity for collisions. So one Karpenter running in that cluster would be looking at node pools and node classes, and you would need a way to delineate, like, are they node pools or node classes for cluster A or for cluster B? And so to sidestep that whole problem, we just made sure all of the CRDs are essentially cluster scope to the workload clusters. That said, you can still run Karpenter in another cluster if you want to. But I think there's maybe two questions here: is where does Karpenter itself run? Can you run Karpenter in a multi-tenant way so you have many Karpenters running in one cluster? And then the second question is, and where do the APIs of node pool, node claim, and node class live? And I think to avoid the collision, because they're global objects, you can't namespace them. They would have to be in the workload clusters without, a major redesign of how our APIs work. But
Yeah.
I'm curious why it's not okay, why you want the Karpenter configuration APIs, CRDs, to be in the management cluster as opposed to the workload cluster.
Well, before I answer that, thank you for breaking that down. I guess the way I'm building the tests for the CAPI provider right now, it's kind of like I'm assuming that the Karpenter objects will be like in the same namespace as some other things. So I didn't realize that they were coming in as like globally scoped or cluster scoped. So yeah, that definitely adds a wrinkle. Then to answer your question, so this is a very CAPI specific thing. It's very common in the hosted, like when we're creating these hub spoke clusters, we put all the cluster API resources in a specific namespace in the hub cluster. And so running things like cluster autoscaler, one of the very popular ways to run it is to put the cluster autoscaler in the hub cluster and, have it close to where the actual cluster API objects are. And this gets into the notion of how operators then kind of like turn these into managed services for their customers. So if I'm creating a managed service and I want to hand you just a workload cluster, I don't want to give you the objects that are necessarily, I don't want to give it into the workload cluster for all users of the workload cluster to see like the cluster API objects. Those would be something that, like a system admin or cluster admin would have control of in the hub cluster. And so we kind of separate the objects that way. And so one of the requests that's coming out of kind of the cluster API community then is, well, we'd like to do the same thing with Karpenter. We'd like to be able to deploy Karpenter in the hub cluster, have the resources for Karpenter namespaced, and then, we don't expose those details to people running the workload cluster, and we can kind of have this separation of concerns for where things are located. So, it's more kind of down to the style of deployment that I think users who are trying to build, and I keep coming back to this managed service thing, but that's one of the ways I've seen it expressed a lot is like, you might have a user who says, okay, for my organization, we're trying to create a platform. And the way the platform looks is that a team opens a ticket in some, system. That ticket comes to us, we launch them a cluster, and we just give them a kube config that goes right to their workload cluster. And then they don't see any of the resources managed by it. And if they want to say enable auto scaling or something like that, then we can give them an interface. They go to that interface and say, turn it on and, give me all these instance types or whatever. And then, some system or administrator would then execute that on the hub cluster, and the users of the workload cluster, then they never see those objects. So they don't have to worry about touching them or like, messing them up or anything like that. So I think it's more, it's less of a technical limitation and almost more of kind of like a social limitation of how people want to build these platforms. And so I thought, instead of trying to go down the complex route of building this like, discriminating client or some sort of multiplexing client, that if there were a simple way to do this in the Karpenter core, that would probably be beneficial, in more than just the cluster API case.
Yeah. I kind of like, the idea of a multiplexing client is super powerful, where you just give a client two kube configs, and then depending on the path, you could do that totally transparently with the current Karpenter architecture, which is super cool. Hadn't thought of that.
And there's research going into that. I think Stefan Szymanski is kind of like working on something similar, but I don't know if it's going to arrive in any kind of like time soon or whatever.
Yeah, you can almost like bind a GVK to a kube config and just let it rip.
Right. That would be like, that was what I was starting to build, was just kind of this like, this mapping where you give it a GVK, you give it a kube config, and then the client can discriminate between what it's trying to do. And, if it turns out to be the case that this is how it works, then, we'll probably continue to go down that route. But I think the bigger concern then, and this is something that again, in the cluster API world, there's a lot of concerns about like, well, where do my cluster API resources live? Do they live in the workload cluster? Do they live in the management cluster? And, some people want to separate them for like RBAC concerns, and other people, they maybe have different concerns or they don't care at all. So like naturally when we look at Karpenter, then it's like, okay, well, where do those things live? Where will they want to live,
So I'm thinking of a way you could hack it. You would need to change our CRD definition to be global. So it's currently, or sorry, to be namespaced. It's currently global. So you'd essentially need to copy the CRD and swap out global for namespaced. And then you would need to do the multiplexing client or something like that. And then you would need to somehow tell Karpenter, you need to inject in the namespace that you wanted it to be. And I think that your multiplexing client could probably also do that. You say, for this deployment, go look at objects with this config and then inject into the request the namespace where you'd expect those to live. And I think that would all just kind of magically work. It's a bit wacky, but I think you could probably do that. So modify the CRD, have a multiplexing client, and inject the namespace.
This is like, pray my plans don't change any further kind of stuff,
I struggle to see us changing the data model of Karpenter at this point. Like the idea that those are baked, like the ideas that those are global are pretty baked. But I think you probably could achieve this with a couple of tweaks. I'd be really curious to see a prototype for that.
Yeah, well, I mean, I guess, yeah, like given what you said and kind of what you're predicting about, not changing the data model at this point, I guess we're going to have to investigate that for cluster API. So you might get the chance to see it in action, I suppose. Thanks, I appreciate it.
One more thing on that is I don't know if a namespace resource could own a globally scoped resource. So if I actually don't know, but if it can't, then you might need to keep the node claims inside of the workload clusters as well, because the node claims own the nodes.
Oh, yeah, I mean, that's something we've talked about on whether or not the node claims should own the nodes, Nick, like with cascading delete. I think that one actually seems like something that, we have talked about breaking that. And I think it wouldn't be a breaking change for us to sever that ownership relationship. If we thought it was super compelling. There definitely is some friction there that Michael's gonna have to work through, but yeah.
Yeah, that's another point of potential friction.
Okay, cool. Well, this is very illuminating, and I will probably leave a comment on this issue later just to kind of cover some of what we talked about here, because I think these details definitely make a difference. And yeah, I did not realize that the node claims were owning the nodes as well. So that, yeah, that's good to know. Thank you, Nick and Ellis.
Alrighty then, great. So unless there is anything else anyone wants to add in there, I guess we'll just open the floor to any questions anyone may have here, since it doesn't look like there's anything else called out in the doc. And if there isn't anything, probably give people a minute or two to see if they come up with something, but otherwise we can probably end early for y'all and for everyone 30 minutes.
Nick, you're Jason, you gotta learn to do like a 3, 2, 1, give us like 30 seconds and then be like going in 3, 2, 1, and then, cut it. You can't like, tease us like that and then just keep going, right?
Oh, that's fair. I had an internal count. I was watching the clock tick down to whatever it is, 29. So we're past that now though. So yeah, I think all at this point, thank you all for coming. If there's yeah, if you have anything else that you come up with after, feel free to reach out in Slack and we'll try and get back. So thank y'all.
Everyone.
Thanks, Jason.